I'm going to be talking about how you can build end-to-end kind of machine learning pipelines in Pachyderm, but not in the way that you'd kind of typically expect, right? What I'm going to focus on mostly today is how machine learning pipelines in general are missing a big thing, which is something called data provenance, which I'm pretty sure a lot of you are familiar with. Let me get started. So, as data scientists, we love, you guys know who that is, right? I'm not that old, right? Okay, cool. That's Data from Star Trek. If you were wondering my geek credentials, there they are. I just used a Star Trek reference in my presentation. But more importantly, we love big data, right? And then we love it when it gets combined with machine learning, right? So these present some pretty powerful options, especially, I'm just gonna take this off the mic because I like to move around, especially companies out there, right? They're thinking, if I take this big pile of data that I've been collecting for years and I apply it to this new field called, well, not new, but this field of machine learning, all of a sudden I get these mind-blowing insights from this stuff, and I'm just gonna hire a bunch of these people called data scientists, I'm gonna give them access to data, and I'm gonna let them run, right, and let them go. And so, Pachyderm, we deal with this a lot, actually. So companies have put a lot of investment into machine learning, and they've hired a bunch of data scientists, and they've given them all this data, and they're kind of just sitting there at their big desks and wondering, when am I going to be Amazon, right? When am I going to be these next big players? And it's because, like, immediately when people get dumped in, they immediately go to these two steps, right? I'm going to focus on connecting data to maths, and then I'm going to expect some sort of output, and then I'm going to be Amazon or Google or OpenAI. And so then we start to even think about maybe some inference and prediction if we're getting real fancy. But in actuality, and I think you guys understand this the most out of anyone, there's a lot more steps involved, right? When we start thinking about a complete holistic machine learning pipeline. And these even aren't all the steps, right? There's still a lot of things to be done. And there's still a lot of things that you as a company may do differently in different steps. But one of the biggest challenges that we really see is in order for machine learning to really reach its full potential, there's three major things that need to happen. One, data itself needs to have the same production practices as code, right? If you think about the last 10, 15 years in software development, code has done a tremendous amount of change with how we deploy it, how we use it. Not just the languages and frameworks that were created, but how we move from one version of that code to the other, right? And I'm more specifically talking about Git, the way we have ability to version control, roll things back, integrate and test it on very specific versions of code, has made it possible what it can do today in production. But data hasn't inherited a lot of those same principles. We've moved a lot forward, we've moved the needle forward there, but data's always kind of stayed in that same static thing. It's something uploaded to an object store, it lives in a data lake, but there is absolutely no versioning. So it's this highly protected resource, and for good reason, but we just kind of throw it at things and then we expect an output, but when we want to explain what happened, it becomes very, very difficult. The other thing is, developers, they need to be empowered, not restricted, right? So we need to give data scientists and developers the ability to work with this data, but not with this impending sense of doom of, if I mess anything up, it's going to destroy everything. That last known good state of data is gone, and I have to email someone to roll a backup that's going to wake them up at 3 in the morning, right? They need the ability to be able to be empowered to experiment freely, but also move quickly and use the right languages and frameworks that work for that project, not because everyone has used that language forever. And finally, organization-wide confidence. And this really kind of comes down to, I think this is personally my most important thing when I think about applied machine learning today in the enterprise, especially if we start to think about responsible machine learning and AI, and data science in general. When we have data and we use algorithms to gain new powerful insights from that data, we need to be able to explain those outcomes at any given point and be able to explain them clearly and quickly. And if we think critically about that and more specific use case, if someone is applying for a bank loan and they're going through the website to do that and they put in all their information, but behind the scenes, the bank has invested a lot of money into training what is a good candidate for a loan and what isn't, if we don't take a look at how we train that model, we create bias, right? And I'm pretty sure you guys are all well aware of AI and ML bias. But the thing is if someone says, especially with things like GDPR, If someone says, hey, wait a minute, why was I rejected? I want specific details as to why my loan was rejected. If the company is using a heavy machine learning model to do that, explaining that outcome becomes very, very difficult, if not sometimes impossible. And so at Pachyderm, where I kind of work to help communities of developers out there leverage the platform, these are kind of the big things that we want to solve. And I'm going to show you guys how we solve that and kind of show you guys our platform a little bit, but more just kind of give concept around best practice and how an end-to-end machine learning pipeline and all the characteristics it really should have to be successful, right? So what are some of the biggest obstacles? When we think about end-to-end machine learning or end-to-end pipelines, there's a lot of obstacles, and these are just a summary of some of the big ones, but I'm pretty sure you have your own individual major obstacles, right? One is data divergence. Really, we can sum this up to, if you change anything, you change everything. So keeping track of all of those changes is next to impossible without some sort of provenance or without some sort of data lineage keeping in play. And if you're making decisions from this, and when you think about models being trained autonomously, decisions and the history of those decisions get lost in just clouds of noise really, really quickly. And then, of course, there's tooling constraints. I use Jupyter Notebooks. I use Python directly. Well, you guys are noobs. I use C++ or, whatever. There's this big argument of which language is better. I was talking about it with a fella at lunch, of whether Jupyter Notebooks are worthy of production or not. And we were just going back and forth, and it's there wasn't a complete opposite side of the stance. It was just we had different approaches to things. And if we want to have teams of data scientists working together to solve a singular solution, we really need to make sure that they're empowered to use the tools that they know best, or at least the tools that's right for the project. Just because the rest of the application's written in Java doesn't mean we need to really introduce Java into this, right? It just needs to be the language or framework that works for the problem at hand. And then, of course, most importantly, again, coming back to that provenance idea, everything needs to be reproducible. If we think about it, we're data scientists. We are scientists. Most machine learning and AI stuff that's happening today is still missing that reproducibility. One of my favorite GitHub repos that I follow is a machine learning paper with code. And it's just a list of all the machine learning papers that also add code, simply because there's this big idea of we're publishing all this great material, but nobody's showing us how to reproduce it and how we can recreate these results. And it's pretty important. And Pachyderm is, it's one of its main things is making results immediately reproducible. And I'll kind of show you guys what that means here in a second. So to kind of sum up that last slide, if data needs the same production practices as code, well, that's version control for data, essentially Git for data. If we need developers or scientists to be empowered, well, that means containers and containerized data pipelines, and that becomes really powerful here in a second, which I'll also show you. But then it's also being able to instantly reconstruct any past output or decision. That's imperative. That's boilerplate. That's basic science, right? If we're thinking about using math to prove something, we need to be able to show our work, right? And so that's data lineage. And these are all things that Pachyderm really focuses to provide from an open source standpoint. I'll kind of skip this slide because that's more businessy and we want to get down to the details. So data versioning, right? What does that mean, right? So we have the ability to identify and revert any bad data changes. If you think about a data set, we actually just released a version 1.8, and one of those functionalities is being able to take structured data and then automatically split it up so it can be distributed across a cluster. But that sounds pretty awesome in a sense, but what it really does too, in the sense of provenance and data versioning, is what was a single database dump or a single file that was structured data, when it gets committed and split in a Pachyderm repo, each row can be split up into its own individual file and then inherits data or like a versioning or a tracking system. So everything gets a commit ID. So what was previously one big commit or one big file can now be split up into chunks where every single chunk has a commit ID and can be tracked back completely. So if we think about, I want to run an ETL pipeline and I want to do all these things to this data to shape it, to prepare it for said outcome, you can immediately recall and go back to what was it that I inserted. And if you look at the graphic on the right, one of these things, is not like the other, right? One all works on the road or driving, one's a boat in water, and we can see how data gets injected sometimes, and it's not like the others. And so we need to remove it, and so we need to remove it quickly, and then not affect the stability of things, right? So that becomes really powerful. And so that's one of the things that we produce, and I'll show you guys an example of that. The containerized pipeline, I can summarize this to really quickly write Docker containers, more specifically Docker containers running on Kubernetes. This is how we accomplish both the ability to give developers with the freedom of the tools that they need to use. This is great for ops. If you have ops that constantly gives you pushback of, oh no, I'm not going to install that because that means a lot of work for me. But if you ask them if they have Docker, they support Docker, most of the time they either say yes or they're evaluating. So Pachyderm leverages containers and more importantly, well, equally importantly, I should say, Kubernetes. And so that gives us the ability to scale, right? And leverage things like GPUs and run pretty much anywhere, right? On-prem, off-prem, in the cloud, hybrid cloud. But more importantly, I think to you guys, what containers and these containerized pipelines really allow us to do is to take our whole pipeline, like I showed you in there earlier, all those steps, and instead of thinking thinking of them as things that we stack on one another, more of like as a kind of string together thing to where everything is independent of one another, and then you can follow the individual output of everything. So one example that we had is I was working with a customer who does genomic data science, and they had all these samples coming in from the field in different areas of the world, and they would have to do, for each individual bench scientist, they had to do their own kind of ETL or their own refactoring of this sample data so they could get it to that bench scientist. And if you imagine for the computational team that was running all this, that was all ad hoc. Everything was independent. There wasn't any really reproducible steps. And so that created a lot of challenges. And so this company was hiring these really brilliant individuals to basically, manage scripts all day. And so that was really frustrating. But when they use Pachyderm, they're able to kind of declare things independent of one another and then tie them together. So where these behaviors are similar but not quite the same, they can define them in different pipelines and then chain these pipelines together. It also, another big thing, and I put in this puzzle piece over here, is the ability, now that code inherits a lot of those production practices or data, we can start doing things like CI/CD in a more real way, in a more tangible way, because we're testing data just like we do code. So one example of I should say pseudo end-to-end machine learning pipeline is a pull request I actually have open in Kubeflow right now. But it's really what it shows you is how you can take data, you can pre-process it, you can version it, throw it into your training. You can then leverage Kubeflow and Selden to not only run that on actual hardware or distribute those workloads, but also use Selden to serve different parts of your model. So that kind of builds on the previous slide of where every aspect of your pipeline is defined by you, and you can use the tools and services that make sense. So if Selden is something that you guys use to serve models out, it's super simple to implement. It's just adding another pipeline spec into your whole pipeline, and it becomes very simple to just kind of chain these things together and maintain provenance and lineage throughout the whole thing. So provenance, which I kind of talked about, I've talked about several times, it's tracking every version of that data in code. So if we input something and then we output something or we change it in between, everything is tracked and everything gets a commit ID, so we can trace it all the way back and see where did this thing start and how did it end up this way. And I don't know about you guys, but that has helped me a lot with some of my models, simply because data gets restructured or changed at one point, moved from one data frame to another data frame, and things kind of merge around. And then I'm sitting there for 4 hours going, why is this thing totally wrong? Well, it's because of this. At one point, I did this structure or this change in my data frame, and it messed everything up. And I wasn't able to really track that without some sort of provenance, which is why Pachyderm has made it so much easier for me to do those things. Quick stack diagram. Basically, like I said, we run on top of Kubernetes. We have this Pachyderm engine that is, that lives kind of on top. We have this Pachyderm file system, similar to, not the Hadoop file system, but some of the same concepts are there. But basically distributed file system across, a large cluster. And then that's all our open source stuff. And we have some enterprise stuff. That's kind of, I think, not so interesting to this audience, but it's like dashboards, statistics and access controls, more of the things that I think ops would be more interested in. But realistically, everything that I've been showing you today so far, you can completely use in our open source engine. It's really powerful and really interesting. So let's go through this in action, and then I'm going to go to a little bit of a demo where we can dive into actual code and examples, which is what I think you guys want to go to. But I think it's important for us to think critically about what we mean when we say data provenance and data lineage and the impact that that has as we think about, or hopefully in the back of your mind, you're thinking about how am I tackling that in my workflows, right? Irregardless of Pachyderm. But if we think about GDPR, I think we all have at least some familiarity with this in some regard. You heard about it, or you know that acronym. But basically, it gives European citizens a bunch of rights to how their data is used and how it's protected. One of those is being able to just the right to an explanation, right? So if you get an outcome, you have the right to get a full human interpreted basic cause of what happened and why it happened that way. But if you have, if these companies, if companies are leveraging machine learning, there's still a lot of that black box. And so if we think about it, if we have a bunch of users in a database and we trained a machine learning model to say yes or no whether someone gets a bank loan, or if I want to make not throwing shade at Amazon, but they wrote a big article about how their job AI system, they shut it down because it was biased towards women for this kind of similar reason. They threw a bunch of data at it, but they didn't really understand what data was being used to train that model. And once they did a really deep analysis, they understood that it had a lot of masculine language in it. And so candidates that had more feminine language in their resumes were getting bumped to the bottom, and they didn't find that out until way late, and millions of dollars were invested. But, and the concept of GDPR, it's this kind of the same, right? So we have this database of users, or database of content or data. We're training it to do a decision. We're deploying that and hoping that everything goes out. Fingers crossed, right? Nobody throws a fit. But with GDPR, that makes it, a lot, users have a backed by law way to get, an explanation of that outcome. And so if you don't have some sort of provenance or lineage, both in terms of technology as well as business process, getting to that output, really tracing back to why that decision was made is a very arduous process and sometimes impossible, which can really create some problems. So, but with Pachyderm, it kind of starts to take a little bit of a different shape, right? So as I said, everything that you put into a repo in Pachyderm gets a commit ID. Think exactly the same way as you check in code with Git. When you check in new code, it gets a commit ID, it's in a repo. It's, then, you can deploy your containers to do all your models, and then you can serve that model out, whether Selden or whatever you want to use. And we get to that same point to where Jared goes, wait, why was, or I don't want my, why was I not approved? Or in this specific case, I don't want my information to be used to create automated systems, which is another GDPR right. You can say that I don't want my data to be used in any kind of automated training way. So what you can do, though, is that's a really simple problem to solve. If Jared raises his hand and says, I don't want my data to be used for that thing, you just can delete that file. The rest, or with the pack control, you can delete it. And then the rest of the data set and all the model gets retrained on that exact same data set. We don't have to call someone to open up a database and find that user record, delete it, then redump it, and then try to get it all the way through the pipeline again. That all becomes automated. So it becomes pretty powerful when you start thinking about not just deletes, edits, or ads, or what have you. So you can see, yeah. So this is Pachyderm in 60 seconds because I really want to get to the good stuff, but I have to go through these slides so that we can go some concepts right. So Pachyderm is an enterprise-grade data science platform that allows you to build these multi-stage pipelines that are language agnostic and maintain complete reproducibility of code and data throughout the entire thing, right? So it's version control for data, it's containerized data pipelines, and then concept around data provenance on top. Is everyone okay? You can guys give me a thumbs up, or if there are any questions to hear, I'm gonna go to the demo. Just a couple thumbs up. I'm seeing a couple, so I'm gonna move on. All right, this I can't do with holding a mic, so I'm gonna drop this here and try to stay still. All right. So let's open this up real quick. Enhance. Okay, and then let me go to our dashboard real quick because that's an easy place to start. So this is my DAG, right? I have some different things defined. These blue hexagons define repos. Think of them similarly or exactly the same as you would a Git repo. And then these green icons are like my pipeline specs, right? These are the instruction set that I'm giving to Pachyderm to do things. And we'll take a look at each one of these. But from the DAG, you can see, oh, here in my images repo, I have a picture of an airplane. And it's just an airplane, right? Nothing special there. And you can see I have one file in there. You can see it was done in one commit. And we can even take a look. And you can see it's on the master branch, right? It has some really interesting information here. And so what happens is I also have this model repo that has basically the pre-trained model from TensorFlow, right? I didn't want to go through training a whole model here. Otherwise, we'd be here until Thanksgiving and we'd miss out on delicious turkey. So I have this pre-trained model, and you can take a look at this pipeline spec, which I think is just easier to open up in the command line. So if I do vim detect, or actually we'll just do model. So you can see this is my Pachyderm pipeline spec. It's incredibly simple. It's just a JSON file. I give it a name. I point it at a repo, and then I point at this frozen inference graph. But you guys I think you guys all generally understand that. I'm just telling Pachyderm to say take a look at this training repo, pull images, and and then leverage this frozen inference graph. In fact, I think if I and then output something. So that's kind of this detect phase too. So that detect model is going to take point in that as well. So if I do detect, this is a little bit more of a detailed pipeline, but same. It's pretty simple. All I'm doing is I'm giving it an input, and in Pachyderm we can give it multiple input sources in different ways, in like joins or crosses. I'll save that for another time. But basically, I'm just saying, take a look at the images repo, and then take a look at that model repo, and then do the object detection, which is that Python inference model, and then there we go, right? So that's the basic outline of these shapes, right? Training is more symbolic than actual reality, because again, we're using that frozen inference graph, but you can see how all these steps are kind of then tagged. So let's take a look and actually put a file in there. So if I go into images and I do pack control, put file, but not airplane, we have dogs, because who doesn't love dogs? JPG, boom. And then, let's see, I'll try to see if I can catch it. It goes pretty fast. Yeah, okay, so that I think is already gone. So we can see in the detect phase, dogs has already shown up, and I should have shown that before, right? That airplane picture, we input it, then it went and did the inference graph, or did the object detection through TensorFlow, and then it outputs the object detection. So airplane was in there to start, but I just put in dog, as you see, and then you can see, oh, look at that, some adorable beagles. And we can do this all day long, right? And so if we do real quick, if I just do pack control, you can see these are the different repos I have. If I do pack control list file, images master, you can see I have my different files in there, and then I can do pack control inspect. I can show you we have a lot of inspect, but if we do inspect file, we can do images, or I'm sorry, detect master dogs.jpg. You can see, I can pull out details here. I'll try to see if I can show you something else that's pretty cool. Let's see if I can catch one real quick. Maybe try to put kites in there. Type quicker, Nick. Type quicker. Oh. I didn't type quick enough. Oh well, we'll see the history of it. You can't, it goes to the old saying, you can't type when someone's looking at you, and I have like 50 plus faces looking at you. So you can see, every job that I put in there, so every time I put an image in that input repo or that images repo, Pachyderm noticed a change, then created a job that was defined by my pipeline spec. So it says, take images from here, use this inference graph to do object detection and then put them in this output repo. And you can see every state is tracked, and then I can see that everything has a commit ID. So every time that model or every time something was done through the image detection, it created a commit ID. So then I can see that if I do, I'm just going to copy this. If I do pack control inspect, oh. You can see that I have a commit ID here, and then I also have a parent ID. And if I go back and trace that, you're going to see how it went through those different things. It had a new child and parent assigned to it at every stage and change. So if I wanted to figure out how this dog or what model was used to detect this dog, this image of a dog, I can immediately follow that all the way back, and you can see the provenance is tracked here as well. So we can see that, look, it came from images, and then its output, and parent are all located here. So you can see that provenance is never lost, as even if it's going from different repos and going through different changes. And so I guess with that, I spoke very fastly through the slides, and I kind of rushed through the demo just because of time. But I want to open it up for questions. Let's throw stuff at me. Let's explore things here if we can. That's the best way to do it. Yes, I saw you go up first, so go for it.
So is there a way to add a stage where I guess I feel like you have to put the image in, like can like the beginning stage be, so can you add I guess like can you add kind of like the stages where the images are a request from like a user and then the end stage?
Yes. So you can use, and I'm just going to go right to here. So his question was, in case you couldn't hear the mic, is he was wanting to know, I did a put file to insert that file into a repository to kick off all the pipeline stuff, but he wants to know, can it just be like automated via like a user request or some sort of hook or cron or something like that? And so yes, so if we go to I'm just going to go to our developer documentation, and I'm going to blow this up as well. And I go to my pipeline spec right here. We have a lot of different ways that you can do that. So you can either initiate it in a cron job, or you can use Git. You can use some webhook stuff as well. But a lot of what people do is, so they time it either via cron to run like every second on something in sort of repo, and then as it changes, every time it changes, it does it. Or you could work it the opposite way, to where your user request, part of that JSON or whatever is telling it to update pack control repo with that. And then once Pachyderm recognizes that, this data set or this repo has had a new commit, it kicks the job off again, right? So, yes. Any other questions? This guy up here in the front? I think it was the second hand I saw. If you're in the back, I'm sorry. Shout, I guess.
Hey, so this may be my misunderstanding of GDPR, but I noticed when you were going through the process flow of removing a user's data, in my head, I was curious if you were going to rebase or delete the history of that. And so to me, if you rebase, you still have the user's data in that repo, whereas if you destroy the history, then that could it would recompute all the hashes and potentially mess things up.
Thank you. You actually kind of caught me on that. So wasn't trying to sneak anything past, but yes, he's absolutely correct. If legally in GDPR, when someone requests to be deleted, that's why I didn't bring that one up specifically, because someone else mentioned it. I just got to change my slides. With GDPR, if someone says, I want to be deleted, that means everything about their data has to be deleted. There is no history of this person. They are then a ghost, right? So in Pachyderm, we can remove that person from that repo, and they won't be used to be trained in any future model. To delete that data, they'd have to go to the database of wherever that user lives and then delete it. And then if they, to really go through it, you'd have to go through specific, figure out every commit in Pachyderm where that user was used, which isn't necessarily difficult. It would just be an extra step, and then kind of removing that from the commit history, and then it would like rebase. But what I was trying to explain is like, so if I wanted to, if I do a pack control, delete file, images, master, dogs, it was dogs or dogs. I can delete that file, and then if I do a pack control list images, master, it's still there. What did I do? Yep, there you go. See, look, again, you can't type when someone's looking over your shoulder. I challenge everyone. Yeah, there we go. Thank you for catching that, good sir. So you can see that file's gone. But realistically, in the commit history and all that other stuff, that would be there. But you would just go through the database of wherever this user information lives, delete it, and then even then you could just kick off your pipeline after removing that file, and the pipeline would rebuild and get a future state to where, or a new model that's trained without the user data. However, so I've had this conversation with some of our co-founders in depth, and GDPR is a good example, and we are working towards like an actual delete. So when we do a delete, how do we go back and make sure that all the hash trees and everything are correct, like that data isn't there? So that's something we're absolutely working towards, but like as a simpler example, you can remove files from pipelines, which is also part of the GDPR, right? You can't use that user's data to train automated systems. So hopefully that answers your question. But good catch, bud. All right, is there any other questions out here? Oh, got a question here, I think. Again, if you're in the back, you're just gonna have to holler. The lights are pretty bright.
You're trying to I'll just yell.
Yeah, there you go.
If you're trying to kind of nice your job, basically, you sure it doesn't run the time or pachyderm to like delay it to like 2 a.m. or
Yeah, so we can leverage cron to do that. So like say we want this job to run nightly at 2 a.m, you can just, part of your pipeline spec could be a cron job that says, go and fetch the latest set of data, and then it would kick off the job and do it then. And you can set that cron job to be however often you want. And what's cool is, because pachyderm is, everything is, again, a Docker image that's then connected via a pipeline spec, and then obviously a repo of data that has all this commit history. Piecing things together and then being able to be very declarative on when things run, how things run, what output comes from what is kind of the whole purpose of it, right? And then again, of course, doing the scale. So we in our recent 1.8 announcement, we increased, which was done, let's see, what's today, Sunday? We did that Thursday, Friday. We upped our scale to be at the petabyte level. So you can scale to like hundreds of millions of files at, thousands of nodes in the cluster. And so like the biggest of enterprises loads can happen in this completely, and Pachyderm be able to orchestrate all that stuff Pachyderm is initiating it. Really, it's Kubernetes that's kind of taking that load and separating across a cluster. And you can leverage GPUs in there as well. So, sorry, I went a little bit past your question, but yes, you can be very declarative all the way down from when your job runs to like what resources it uses. So hopefully that answers your question.
Can I add one more? Okay. Are you compressing data at all?
No.
Okay. So it's just massive amount of raw data. It's up to the user to compress it.
Yeah, I think, it could be part of your pipeline to compress data if you wanted. It's all about you. Again, it's all about how you want to declare things to be done. If you have a step in your pipeline that does compress data, you could do that, but by default, to my knowledge, and I could be wrong, I'm on record here, I think, via the recording, and someone may go, oh, no, absolutely you can. So, as far as I know, we don't compress any data outright. Like, it's not a default behavior. But I'm sure, if that was part of your pipeline, you could do that. Any others? And try to keep an eye out in the back. All right. Well, what I'll do is, because usually when I go to talks like these, people leave it at a demo, but they don't really give you a concept of like where to go afterwards if you want to play with it at home. So really, like I said, we're a bunch of open source nutcases at our company, and so we pretty much do everything on GitHub. And we have a Slack channel that's also available open for users, so you can join. I'll just pull up our website real quick, not to promote our product, but really so that you can just see if you want to get involved, ask questions without being, like super pressed for everything. We have a Slack channel where you can join in. You can ask any question you want. Doesn't matter how simplistic or difficult. We all are very focused on that. Our GitHub is another great place to go to find information, see what we do, more discussion. We are also starting to, with every release, really starting to put out more blogs about kind of giving more insight into the back end of why we changed things the way that we did, and more on an engineering level. So if you want to see like how we changed to go from like the scale we were at previously, the scale we are now, we have a great blog post in there from one of the engineer who did all that, who explains like why we changed and how we changed things on an architectural level. I'm not that smart, so I'm not even going to try to revert it because it'll sound all kinds of broken coming out from me. But it's a very cool post from him to take time because we're just all about being transparent and sharing information. But we have a lot of really good documentation and examples to cover just about a lot of so many different use cases. We go, we can do database stuff, we can do genomics pipelines, Jupyter notebooks. We have some like ML stuff. The one that you saw today that I was doing is object detection. So you can follow this example outright. Just lots of really good ways for you to put your hands on it and see how you can take even, any kind of data that you have, and then immediately, within just a few seconds, it takes 2 minutes to deploy Pachyderm. All of a sudden your data just starts inheriting this lineage, this provenance that you can use, and gives your models a lot more of a scientific approach, which is incredibly, valuable on multiple fronts. And as far as I know, I think we're the only company that provides this information or does that data provenance at this kind of scale. But yeah, so check out our GitHub page, jump on Slack if you want to ask questions, and that's really it. Unless you guys have any other questions, and I highly encourage them. There are no dumb questions except for the ones that don't get asked. Oh, there's another one. Yes.
Have you seen, I guess, so when this pipeline is in production or used on some team or with some team, and they have tons of images, right? Tons of data that when you try and pass it into a different stage, into prediction at large batches, is that already just easily taken care of? Just from the pipeline itself?
Sorry. Go ahead. I was listening. Yeah. So if you're asking about, so you have these, so say you have these different lakes. I think you have 2 different data lakes, is that what you're asking? Or you want to move data from one side to the other?
Or, I guess it's just, how well have you seen this perform when your database or the data that's coming in is really large, but the scale's really huge?
Yeah. And again, this is Pachyderm, but more so I think the beauty of Kubernetes, when we can take what we can do. That's why I was really excited about this split functionality we did with our 1.8. You can take this really large data set, and I have a blog out there, I could show it to you really quickly, but what we can do is we can take data in a single structured file, split it up into however many files, and we can specify how many files we want to split it up into. So by default, Pachyderm will take a table of rows and make each row its own independent file and store the header information with that file. And so it'll create X amount of files, however big your row is. But you can also tell Pachyderm to say, okay, instead of an individual file for each row, I can say I want every 10 rows to be an individual file in Pachyderm. So how that applies to large data is whether it's structured or unstructured or what have you, it's all in an object store to begin with. So it's how you move store things from one object store to the other is going to really depend on speed. But as far as Pachyderm ingesting large amounts of data, it's as simple as a put command, and it just kind of goes and either breaks it out or does it. But that job, that independent thing is spun up as a Docker container to do all of those things, and then they get spun down. So it's really like Kubernetes that shines in that regard, but that scale is there. All right. I think that's it, unless I'm seeing any hands. All right. Go once, going twice. All right, I'm going to be sticking around too. My flight doesn't leave until later, so if you guys have any questions that you just didn't want to be on the spotlight for, feel free. But thank you for your time, and thank you for, everything.